This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. This episode of Fluid Power Forum is also sponsored by Endeavor AI. Endeavor AI automates order entry, quoting, and the quote-to-cash process. Win more, sell more, and save time, all without adding headcount. Head to endeavor.ai to learn more. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of the show, you can follow us on LinkedIn. We're there at the National Fluid Power Association. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with our hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You'll find us on Apple Podcasts. We're on Spotify. We're on all the other popular podcatching services. Wherever you find us, go ahead, subscribe to the show, and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. On today's show, my guest is Jon Frey, the head of product area new business at Bosch Rexroth. A giant in the fluid power industry, Bosch Rexroth produces a vast range of products for both hydraulic and factory automation motion control system solutions. On today's episode, we'll be focusing on hydraulics and how they can be used to conquer the seas, ensuring stability in the harshest of environments. We asked Jon into our forum to talk a bit more about the nature and the challenges of that work, some impressive achievements, and what the future might hold. So, Jon, welcome to Fluid Power Forum.
Hello, Eric. Good afternoon. How are you?
I'm great. We're glad to have you back on the show. And I know we're going to talk about hydraulics in maritime applications and some exciting developments and achievements that Bosch Rexroth has done in that space. But before going there, tell us a little bit more about yourself. Tell our listeners a little bit more about yourself. What is your background and how did you find yourself working at Bosch or Rexroth?
Oh, thank you. Yeah, so I guess you start out in the beginning, which now is a few decades ago. I began as a hydraulic field service technician, primarily for presses, plastics machines, and some of our earlier electrohydraulic applications like the servo proportional controlled system solutions. After my stint in service, I became the trainer or a trainer for the hydraulic courses that we offered through Rexroth at that time. My degree is actually in education.
Oh, okay.
And then after a couple years of the training department, I transitioned into product management for the industrial hydraulic portfolio, and I served that role for, more than 20 years. And hard to believe already, but it was about 10 years ago, I was the distribution channel manager for Bosch Rexroth before being offered the opportunity to lead the product area new business engineering team.
Yeah. That's a long career at Rexroth, no offense, in terms of how many years you've been there. And you've been at Rexroth the whole time. Did you work anywhere else before that, or?
No, I went from substitute teaching and filling in for a gentleman on sabbatical to Rexroth.
Wow. And so your degree, as you said, is in education. So you're not an engineer, is that right?
Correct.
Wow. Well, neither am I. So welcome to the fluid power industry for the non-engineers that are out there. You certainly know your way around, I'm sure, fluid power and hydraulic systems from all that field experience.
Well, or you could say everything I say is suspect, right?
Well, let's not go too far down that road. So, well, that's interesting. That's an interesting background and a lot of varied experiences through the Rexroth. Tell us a little bit more about Rexroth as a company. What is it that they do you think, and what markets do they serve?
Yeah, so I'd say we are a market leader in drive and control technology, delivering both components and systems to provide motion control solutions to the industrial and the mobile market.
Hmm.
I'd say our markets span hydraulic, electric, automation, control architectures for both in-plant installations and mobile machinery, for example, like construction, agriculture, and various off-road highway application areas. Having a broad portfolio and utilizing sales and application engineers, we can offer custom or unique motion control solutions across many of these application areas. And our solutions can often be scaled to meet evolving market demands and also be cognizant of disruptive technologies such as the efforts towards electrification, as an example.
Yeah, there's a lot of different applications just for fluid power in a normal way, but it sounds like Rexroth is really focused on some of the cutting edge areas.
We try to.
Yeah. Well, and I think that's what we'll talk about, So we talked about maritime applications. I'm curious to find out like what exactly that means. So maybe talk about, just generically speaking, where do we see fluid power in maritime applications? What kinds of things are we talking about there?
Yeah, I'd say if we look at fluid power and let's just say primarily hydraulics in this instance, we might be considered like the backbone of the heavy duty applications in the maritime sector
Yeah.
due to our high power density and our ability to control very precise. Hydraulic power critical systems like winches, cranes, steering gears, thruster, marine stabilizers, mooring or active heave compensation solutions, which allow for controlled motions even in those harsh conditions. And I'd say the robustness and reliability of hydraulics really make it ideal for that demanding maritime environment.
So these are applications that are either steering a boat or doing work on a boat, or am I summarizing that right?
We can do steering, but that most of what I mentioned was probably more above deck.
Yeah.
There were some things with steering gears, but with cranes and winches, and then below deck steering, as you mentioned, or like bow thrusters and stabilizers and so forth. Mooring and active heave compensation deals with loads under the water, but
Yeah.
typically the equipment is on deck, if that helps.
Yeah. I'm just trying to get my head around, and trying to visualize what some of these applications are. So, for example, you mentioned mooring control as one particular area. Tell me more about what exactly that is and how that works.
Sure. So mooring control, or let's say a constant tension circuit. Mooring control, for example, refers to a system or an operation that utilizes a relatively small disruptive force input to control a larger or a heavier mass in direction or position. And in English, what that could mean is if I had an example, maybe a large milling machine head where I need a fine positioning actuator, and I couple that to a mooring controlled actuator so that I can achieve highly precise movements. And I only require the fine positioning actuator to either upset or offset the counterbalancing effects of the overall mooring circuit. And alternatively, in reference to today's topic, mooring controls can manage a vessel's position relative to a fixed anchor point,
Mm-hmm.
like a dock, or a specific location. And in this context, for us today, it's vital for maintaining safety, preventing collisions, ensuring efficient cargo transfer or offshore operations, especially in the dynamic marine environments.
Yeah. So this is essentially keeping the vessel still, or still relative to the dock or the platform, even with regard to what the waves and what the motion of the water is doing.
Yeah, and it can be even less elegant than that. If I have
Yeah.
a ship at a dock and the tide comes in, the tide goes out, how do I deal with the movement of the ship up and down in the tide? How do I account for slack on the mooring ropes, for
Yeah.
example, or the mooring chains?
Well, that sounds like one of those applications where hydraulics is ideally suited for it. I mean, you're talking about moving something very heavy in a very precise way, right? To make sure, and there must be a lot of moment-to-moment compensations that need to take place.
Again, tides are less dynamic
Yeah.
than active heave compensation, for an example. But
Sure.
yeah, the basic principle of a constant tension circuit is there.
Well, talk about the active heave compensation then, in terms of give us some more information on how that works.
Sure. So active heave compensation, or sometimes it's nicknamed AHC, it's a technology designed to counteract the vertical motion or the heave of a vessel caused by waves.
Right.
Essentially, it keeps a suspended load like an ROV, like a remote operated vehicle, or drilling equipment virtually stationary in relation to the seabed or fixed point, irregardless of what the vessel's doing. So the vessel can be moving up and down in a wave action, but the load, the tethered load, stays stable or in a position relative to the seabed or seafloor. Active key compensation systems use sophisticated hydraulic controls to achieve this precise stabilization. And oftentimes these more modern systems may even be combined with the more traditional chain and wire lines with advanced systems in winches and sensors. And then lastly, active heave compensation can even be used in conjunction with dynamic positioning systems, which are like bow thrusters or stabilizers or even propellers. These are all crucial to keeping and maintaining a precise position on a vessel that don't have a fixed mooring. So if I'm out in the sea, I don't have a dock. I'm not located to a specific point. So I kind of have to keep the boat in a position to enable the active heave compensation to keep the load in position.
Yeah. There must be a lot of, again, sensors and feedback associated with a lot of that active control of the system to do those kinds of functions.
Yes. Yes.
Yeah. So these are some good examples of the kinds of applications that you work on and that you provide the hydraulic solutions for. What are some of the major considerations? I mean, the design work that goes into these systems must be intense. So, like, what are some of the considerations that are unique to this environment that you have to pay close attention to when you're building a system like that?
Sure, I would believe some of the major considerations would include the precise measurement of the vehicle or the vessel heave, not the vehicle, the vessel. We need to consider some dynamic response times from the hydraulic system and the utilization of robust components that are capable of continuous operation in such a corrosive marine environment.
Right.
I would say environmental factors like strong currents or high winds or significant wave action always create constant challenges to maintaining a stable mooring. Also, seabed conditions, or how well is the anchor holding, or if there's subsea infrastructure. All these things can complicate the process and require some careful planning and possibly some real-time adjustments when you're out in the field. And if you look at some of the methodologies or the topologies of the circuits, typically they involve accelerometers or motion reference units to detect the heave. These send signals to a reactive hydraulic winch system that may pay out or pay in cabling to stabilize the load. And if I use our active heave compensation solutions as an example, we use advanced sensors, high capacity hydraulic cylinders or motors, sophisticated control algorithms to achieve accurate heave compensation. And utilizing these technologies, they can reduce downtime for the operator. They can reduce the risk during critical operations like these subsea installations or drilling, enhancing safety, operational efficiency, and trying to ensure a stable deployment even in rough seas.
Go ahead.
No, I was going to say, lastly, the continuing improvements to these automated monitoring systems and even some predictive modeling of environmental forces and some real-time data analysis, we can even hope to alert operators to potential issues, possibly enabling them to make a proactive adjustment, before things go wrong.
Yeah. Yeah, I was going to ask about the experience that the operator sees. I mean, this sounds like a very sophisticated hydraulic system. How much of a hydraulics expert do those operators need to be? How much of this happens? They're just worried about moving the load or whatever it is that they're doing on the boat, right? There must be a lot of feedback to them in terms of how to manage and control these things. Can you talk about that?
Well, a little bit like we talked about accelerometers or these motion reference units, which I think are MRUs in the lingo. There's a lot happening with the control architecture so that, let's say, the operator doesn't necessarily have to predict or react to every piece of motion, but if certain parameters are set, limits, hey, if you get above a certain wave crest or you get this occurring, then you need to react, and that's more, I think, what the operator must stay cognizant of. Of course, it's a rather large task
Yeah.
depending on the load and what you're suspending
Right.
in the sea.
Yeah. Well, and I'm sure it's an area that's, fraught with danger in most cases, especially if the seas are rough or if there's other environmental challenges associated with it. It's not simple work, is my impression at least.
And it's always moving.
Yeah.
It's not like a facility that's on land, huh?
So is Rexroth then also providing kind of the interface, the electronic control interface for these systems that the operator
We can,
uses?
yes.
Is that
Yes,
okay?
we can do more and more integration of our content, and if the customer so chooses, we can expand that. But typically, whatever is done has to somehow integrate within the master ship's control architecture.
Yeah, right. I'm curious, like, how nichey is this? Like, is this these technologies or these products or these systems that you develop for these environments? Are they only for these kinds of applications, or are there other underutilized areas that those same systems could be used for?
I mean, if we stay within the ocean, I'd say, yeah, there's more opportunities, but I guess to address your first question of, are some of these components unique to this kind of an application? Not necessarily. There may be coatings or corrosion resistance or certain attributes of the product that are quasi unique because they have to survive in that environment. But axial piston pumps that can go over center or secondary controlled motors, that's part of the portfolio. We use those on test stands. We use those in other areas of non-floating markets.
Yeah.
But again, for corrosion resistance and coatings and things like that, there could be some unique properties for the components used.
And do you think there are other areas that same technologies could expand into that they could be used, but they're not currently?
Well, if we stay within the sea area, I'd say beyond the traditional subsea construction and drilling, I believe active heave compensation could also help with like offshore wind farms. Again, if you're trying to enforce or enhance safety and the speed for personnel transfers or moving equipment onto repairing a wind farm, it's an interesting challenge to replace heavy components on something that's moving up and down onto a device that's stationary.
Yeah. It's a
And I'd say beyond that, I think there's some opportunities with high seas logistics, stabilizing the container handling process or the transfer process, or even in refueling operations between moving vessels where their stability is obviously paramount. So I think there's some opportunities for additional application areas that this technology could be used in, or a variant of it.
Yeah. And because given the forces involved and the loads that need to be steadied or moved, I mean, again, hydraulics is kind of the solution for this. Are there any competing technologies that are invading this space, or is this really a hydraulics application through and through?
There's some efforts with electrics, like full electric winches. I'm not sure. I don't honestly know what the limits for those are. In other words, you have a very good question there. Up to a certain point, could I displace hydraulics with electrics?
Yeah. Well,
possibly.
I'm not asking you
But
to
I
do that, John.
suspect-
So to be
I'm
clear,
sorry?
I said I'm not asking you to do that. Just to be clear. So we're hydraulics fans here on the podcast. So
That's fine. But in again, part of my product area, new business,
yeah,
you have to kind of think about emerging technology. So yes,
right.
I guess there's always a threat there, but I suspect there's still a certain breakover point where hydraulics just has the attributes and the advantages for power density, and robustness.
Yeah, we see that in a lot of applications, and so that's great. Well, where do you see this technology advancing in the future? Do you have a crystal ball? What do the next couple of years look like for this?
If I look at my cloudy crystal ball, I guess we'd have to fall back a little bit on some of the things that are happening in general. I don't know that it would be what I'm going to say. I don't think would be specific to active heave compensation
Yeah.
or mooring controls, but I think we would anticipate even a greater integration or use of artificial intelligence and or machine learning to improve or maybe even leverage more predictive motion control.
Mm-hmm.
In other words, instead of necessarily waiting for a sensor to say, hey, something moved over time, could I kind of get the lay of the land and say, well, I kind of know what the tidal motion is and the frequency and the wave breaks.
Right.
These are things I can do with artificial intelligence that reduce I have to wait for real-time data to have an idea what's going on. And I believe as that could be incorporated into the circuits and the systems, that could even bring additional autonomous operation, which you kind of hinted toward. Boy, that's a big job for an operator,
Right.
and
Yeah.
you're not necessarily in always the most calm and safest environments.
Right.
So adding autonomous operations, keeping the human safe in the equation,
Right.
could also be a benefit. And then I suspect even if we don't want to go down the artificial intelligence path, just advancements in real-time data analytics and condition monitoring could support strengthening predictive maintenance schedules, which could even help further increase uptime and operational efficiencies in these critical solutions. So
Yeah.
I don't wait for something to break.
Yeah.
I have data and documentation that says I need to replace this thing or plan to replace this thing rather than wait for it to fail.
Yeah. The AI angle is an interesting one, as many things are that you described there. But I would imagine like this is an environment where there is just a ton of data in terms of what's happening. The sensors that have to monitor and control everything over time could generate a lot of information that an AI unit could be trained on to better anticipate, when we see this pattern of waves, then this is what's likely to happen next. It's that's an interesting subset, if you will, of the AI intelligence area. Would you agree?
Yeah, again, looking at my cloudy crystal ball,
Yeah.
you asked, and I think that could be an area where this technology even gets more benefit from AI and machine learning.
Yeah. All right, then. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Jon Frey, who has been my guest on the show. If you want to connect with him, learn more about these technologies and these systems, the best way to do that is to send him an email, and we will put a link to his email address in the show notes for this episode. Remember, if you like our podcast, and we hope you do, please follow us on LinkedIn at the National Fluid Power Association. And make sure you keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from you about the kind of topics that we should be addressing on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.